I'd like to wrap up by pointing out that the way we've answered those first 5 questions about allocation uh, can have very different answers in different strategies of allocators. And one other common choice of allocators you might call a segregated allocation, where you make chunks of memory, pages or something like that, and on each of those chunks all the objects have exactly the same size. All of the blocks have the same size. The reason this can be simpler is you don't have to put a header and footer on every block. You know exactly where the blocks start and stop based on the arithmetic in the block. You don't have to put necessarily the allocation bit with each block. You could have a little bitmap at the beginning of the chunk that says which of the blocks are allocated, and then even if you're searching through a bitmap to find a free block, that can be very fast because you're searching bitmaps that have 32 or 64 entries in them at a time. Um, and you just have to keep an array of pages or page chunks for each size, maybe every power of 2 as I've shown in this diagram. So this kind of allocator would answer the questions that we set out at the beginning quite differently. How does free know an allocated block size? It's based on the chunk that it resides in, and maybe there's a mapping from chunk addresses to sizes, or maybe you just these chunks are powers of 2, and so you just strip off enough bits so that you find the beginning of the chunk, and it tells you at the beginning of the chunk information about the size of all blocks on that page. How is unallocated space represented? Like I mentioned, you might have a chunk-specific bitmap at the front instead of strewing bits all throughout, intermingled with the payload. How is unallocated space selected? You could still have a free list with a pointer at the start of the chunk, or you could use that bitmap and just search the bitmap. How finely is unallocated space tracked? This is where this is one of the main trade-offs, is that you have to round up all allocation requests to something that matches some chunk's size. So often these chunk sizes are powers of 2, or maybe a few small sizes and then powers of 2 as you go to large sizes. And then when there are more pages needed from the kernel, we're allocating in groups in chunks. So when for a given size you have no chunks that have some empty space in it, then you have to allocate a whole new chunk.